All right, welcome to Chapter 3 in Hot Topics. We're going to start with systems of equations and end with word problems and some inequalities in this chapter. And the first thing is understanding the basics, and we're going to start with the basics right here with solving systems. Any comments on this one, Bill?
No.
Just go
Take
at
it away, yeah.
All right. When we solve systems of equations, in our textbook, we outlined a few methods. As far as Alex goes, there's only one, and it's elimination. So we're going to keep it simple. It's the method that works for every situation that you're given.
Right, and in most cases, it's often the fastest. We can create equations where one of the other methods will be faster, but we have to kind of rig them to work that way. If you really want to focus on one method, this is the method we recommend.
Now, when you solve a system of equations, the first thing we normally try to show in a classroom is what is it that you're solving for? Because once you understand what you're solving for, typically you'll never write the answer improperly. If you were to graph these two lines, and I'm just going to make up graphs here, but if you had two lines that you know had different slopes, the solution to these two lines is the point where they intersect, which is an x value and a y value. That's in essence all we're doing. Instead of doing this graphically, which involves estimation and a lot of level of preciseness that you really can't do, we're just going to solve these algebraically and come up with that xy value, which is the one point and the only point that they share. Now we will show one situation where there's a different type of solution, but over and all, what you're solving for in Alex is one point of intersection.
And particularly in word problems, you're looking for the x value and the y value that make both equations true. That's equivalent to the place where the two lines intersect.
Okay, so to get started with the elimination method, the first thing you want to do in your head is go, if I add these two equations right now as they are, will I end up with one variable or two variables? So when I look at this, I see 2x plus x is going to give me 3x, and then negative 3y plus 5 is going to give me... In other words, I'm going to end up with an x and a y if I add these together now.
And that's not what we want.
No, we want to eliminate one of those variables because we need to solve a one-variable equation. So what I'm going to do is I'm going to multiply the second equation by a negative 2. Now, at first you might say, well, where did that come from? Well, notice, I see that 2x is up here, and this is really 1x right here. So negative 2 times 1 is negative 2. When I add them together now, they're going to cancel out. But before I do that, I need to rewrite the whole equation. In other words, I have to distribute that negative 2 on both sides times every term. Now, after I do that, I normally encourage the students to rewrite the other equation, the original, right underneath. Keep your paper nice and clean and neat as you go through this process. Now we add the two equations together, and you'll notice these cancel. So you're left with negative 13y equals negative 13. How nice. Divide both sides by negative 13, and you get y equals 1. We're halfway there, but we've done most of the work. Once you have the 1, you can substitute it into either equation. I'll go ahead and plug it into the first equation, and that gives me 2x minus 3 times 1 equals 3. So that's 2x minus 3 equals 3. Carry that 3 over so it'll become positive, and then divide by 2. So the x value is 3, the y value is 1. So at the point 3, 1, these two lines intersect, and that is the solution to the system.
And that's what we're after.
That's it. Okay, this next one. Now this next one, I intentionally made this a little bit more difficult because you'll notice that one multiplication will not eliminate both variables, or a variable in this problem. We're going to have to multiply both equations by something to get something to cancel out here. So it's your choice. Just for the sake of it, I'm going to get rid of the y values this time. So I'll multiply this equation by negative 2, this equation by a positive 5. Now before you go through all this work, double check. Negative 2 times 5 is negative 10. 5 times 2 is positive 10. So I know the y's will cancel out. So here's my new equation here. 5 times negative 3, negative 15x plus 10y. And 5 times 19, I believe, is 95. And then carry this one down. Negative 8x minus 10y equals positive 20.
Right. Notice that we multiply by the negative 2 and the 5 on both sides of the equation, not just on the left side. Watch out for that. It's a common mistake.
Very common. Okay, these cancel, and that was the point of this. So you end up with negative 23x equals, and that's going to be
115.
115. Now we hope 23 divides 115 evenly, and I believe it does. I believe it divides it negative 5 times.
Right, and Jerry and I know that because we did this problem before we actually started filming. So don't think that we necessarily know that off the top of our heads.
Okay, so once you have negative 5, now substitute it into either equation. Again, I'll plug it into the first one. So that gives me 4 times negative 5 plus 5y equals negative 10. Now again, just to clarify, you solve for x here, so you must substitute an x value or the x variable in that equation. Don't substitute it into y, because then you'll get a totally different answer. So 4 times negative 5 is negative 20, plus 5y equals negative 10. Carry that negative 20 over, so it'll become positive over here, so you're going to end up with a positive 10 on this side, and then dividing by 5 gives you a 2. So the answer, negative 5, 2. So you can see, not overly difficult. What you're doing is you're rewriting these equations to make them where you can cancel something out. So we have one case left to show you.
Right, this is an unusual case, but these are cases that you will occasionally see, so you do need to know what to do when this happens.
Okay, looking at this one, you'll notice that 4 is a multiple of 2. So if I'm going to get rid of the x's in this one, I'm going to multiply this bottom equation by negative 2. So my new equation becomes negative 4x plus 2y equals negative 16. Now again, rewriting my numerator.
It's not your numerator, it's just
not
your
my
first
numerator,
equation.
my top equation.
It's okay.
4x minus 2y equals 7. And something amazing happens here. You lose the x's and the y's. They're all gone. Now, Bill and I have taught this enough to know that students tend to not like that, and they'll just carry something down. In this case, it's best to just write a 0 equals, and over here you're going to have negative 9, and then you ask yourself, is that true?
Right. Is this a true sentence? If it's a true sentence, then the answer is that there are an infinite number of solutions. But in this case, notice you get a sentence that's false. 0 is not equal to negative 9. That tells you that this particular set of equations has no solution. And in fact, if you graphed these two lines, you would see that they are parallel. Parallel lines never intersect. That's why these two equations have no solution. And Alex has usually wants you to write no solution with that null set, I think.
That's it.
Thing. So usually that will be, I think, the what's written there. Although occasionally, does it actually have a button for no solution as well? I forgot.
It might. You just know that it's going to be an inconsistent solution or no solution. But the bottom line is this can happen. It does happen. Because obviously there are sets of parallel lines.
So to summarize, because there's lots of different ways to focus this, the equations are said to be inconsistent because they don't have a solution. But in terms of x and y, we say there's no solution. And although Alex won't ask you this, it's nice for us to let you know that the lines are parallel. So the answer is don't panic if you end up with 0. This can happen, and that's why we wanted to make sure we did an example of this.
That's it. All right, if you need more work, look in your book, Chapter 3, early on, and we will see you in the next hot topic.